Hello, I'm Greg Krinklaw, the developer of SkyTools. I'm outside, it's getting dark, and I am ready to observe. Tonight, we're going to explore the real-time tool for visual observing and its various workflows. The real-time tool came about when I realized that the nightly planner did a poor job of telling you which objects to look at when you were already outside under a dark sky. So I decided to create a separate tool dedicated to use at the telescope at the current time, as read from your computer clock. In other words, it would always work in real time. This tool can directly control a GOTO telescope or a scope connected via digital setting circles. But it's important to remember that you don't need to use either of these. You can think of the real-time tool as an assistant, there to help you decide what to look at right now. Ultimately, this tool is meant for use at the telescope, regardless of how you observe. Remember, other software can make lists of objects and generally tell you what to look at, but SkyTools takes that a big step further to ensure that you always get the best view, or the best chance to detect a challenging object. Sometimes people want to use the real-time tool for other purposes. I'm sometimes asked to be able to sort by columns, for example. Just as you wouldn't use a screwdriver to work on your pipes or a chainsaw to make furniture, it's best to use the appropriate tool for the job. These tutorials will show you the entire workflow and how the different tools are intended to be used together. In the process, the role of the real-time tool will become clear. There are two real-time modes, Best Now and SkyTour, and there are separate sets of workflows for each. The three main ways to use SkyTools in the field are to use on-screen finder charts to find your targets, a GOTO telescope, or a DSC connected directly to SkyTools. I've created multiple videos depending on which of these methods you use yourself. If you don't use either of the telescope control methods or the finder charts, the real-time tool can still help you find timely things to observe at the telescope. In that case, I suggest watching the tutorials for using a GOTO telescope and adopt a similar workflow for whatever method you use to find things in the sky. The planning process begins before we go out to observe. In my case, it was a few days ago. Our workflow begins with the nightly planner. One of the core principles of SkyTools is to plan your observing in advance. Now what that means is to find some great objects to observe before you go out to the telescope. The idea is to use the tools to find objects that are best observed on the night you plan to go out, and then put those objects in an observing list just for that night. These are the steps that we use the nightly planner and its associated tools for. When you go to use the telescope, the real-time tool tells you which objects in our final list to observe at any given moment. So we start by making a list of objects that are good on that night, and then the real-time tool tells us what time to look at each of them. I'm going to plan for an upcoming night using an 8-inch telescope as an example, and then I'll go out and observe on that night using the real-time tool. Now, if I was doing a special project such as the Herschel 400, I could skip this next step where I use the nightly planner to create a custom list and just load the Herschel 400 list into the real-time tool when our night comes. But when we want to observe a lot of different things, we use the nightly planner to create a custom list for that night. I've set the planner for March 24th, an observing location nearby, an 8-inch telescope, and me. The next thing to do is to set up the weather. Never forget the weather. I can't know exactly what it's going to be that night, but a good estimate would be a temperature of 40 degrees Fahrenheit and a humidity of 45%. I'll set the scene to be good. I'll be going to bed at 1 a.m., so I'll drag the right time slider to 1 a.m. I could also have typed it in here as the to time. I'll also tell it that I won't be set up until 7 p.m. This will tell the planning tools not to plan before or after these times. Remember, planets can be observed in daylight, and sometimes they are higher in the sky then, and better observed. The setup time will keep SkyTools from suggesting anything before we are ready. I'm going to create a new custom observing list via the List Functions menu. I'll call it March 24. The quick way to plan is to use the Nightly Observing List generator. So let's start with that. What this tool will do is to use the location, telescope, and night from the Nightly Planner. It also considers the time range that I just created. There is or will be a tutorial about using the Nightly Observing List generator that goes into more detail. I'm going to just touch on it here. A good place to start is showpieces. This one's great for a public event where you only want things that are bright and obvious. But it's also a good place to start in general if you want things to observe with little extra effort. For planning for a star party or any other night months in advance, it's best to use this tool close to the actual date you plan to observe so that the comet and supernova information will be fresh. The results are placed into a new list that is automatically created for this location and this night. I'm going to just take all of these. To do that, I'll right-click on the multiple selection column and choose Check All. Then I'll right-click in the column, it doesn't matter which object, and select the custom list I created earlier. This will copy all of the objects over. Now let's run it again, but for the NGC IC objects. I could append these objects to the list that the tool already created for this location and night in order to build on what we already had, but in this case, I'm going to just overwrite it. Once again, I'm going to just copy all of them. Here is the list for March 24th that I've created. It has 49 objects in it. I'll remove the ones that I've already logged. I'll right-click on the log icon and select Check All Log Entries. Then I'll right-click in the checkmark column and select Delete Checked Entries. This brings us down to 35 objects, which is a good number for 5 hours of observing. Now, that's the quick way to do this. But let's look at another way to choose objects for our list. I recommend keeping a special list of objects that you want to observe some clear night in the future. Maybe you see an HST image or read an article and think it might be cool to try to observe the object visually. So you'd add it to your special list. Here is an example list I created called Cool Objects. It's got its own attachments folder where I can keep track of why I wanted to observe them. I need to filter out the ones that aren't good on this night, as well as the ones that are too faint for this scope. So I'll set the filters to best quality only and visible at any difficulty. Looks like our only candidate is the Polar Ring Galaxy, NGC 4650. I'll right-click on it and add it to my custom list. I always want to add whatever telescopic comets are available. We added a couple already via the Nightly Observing List generator, but that tool is designed to give us a sample of really bright objects, not every single one available. So I want to add more. We'll go up to the current lists and open the current comets list. Comets tend to hug the horizon, and you can't necessarily look at them on a better night. So I'll relax the quality filter a bit. I love comets, so I'm just going to add them all. We can do the same for supernovae. Sometimes you may get no results using the best quality and visible at any difficulty filters, and that's okay. It just means that there aren't any visible in your scope that night. Another approach to finding objects is to use one of the pre-made observing lists. I'm going to load the Royal Astronomical Society of Canada's finest NGC list. I'll ensure my filters are set to best quality and visible at any difficulty. I'll also filter out the ones I've already logged. Let's see, the Ghost of Jupiter might be good, but is it large enough in the scope? I'll right-click to view it in the telescope finder chart. I could also press T with the object selected. It looks like it should be fine in my 8mm Radian, which has also been picked as the ideal eyepiece. So I'll check that one. What's this lost galaxy? That should look pretty good. I'll open the object info to learn about it. The catalog notes say it was discovered by William Herschel and that it's pretty faint, very large, and resolvable. Okay, I just did some Googling, and apparently Leland Copeland named it in the 1950s because its faint ghost-like appearance. I'll check it too. Now I could add more, but you get the idea. Use the tools on hand, such as the object info and the charts, to help you decide whether or not to observe an object. I'll add these to my custom list. Lastly, let's add some double stars. I'll load the most beautiful double stars list. For these, I'll add a splittability filter. Let's make it good split or better. I'm not that interested in challenging observations for these. Let's sort by the best time to observe so I can pick a few pairs to look at during twilight. I'll look for a fairly evenly matched pair. This pair looks good. I'll also open a chart. I can't see the separation because of the resolution of the monitor and the size of the stars drawn. So for the eyepiece, I'll select Match Detail. This will give me an idea of how well I can split the pair. It looks like it'll be a good one, so I'll copy Lambda Ori over. Again, I could add more, but you get the idea. Now that we've created the list that we're going to use, let's have a look at the real-time tool. It has two modes. They both work from an observing list. The Best Now mode is more freeform and relaxed, allowing you to observe at any pace and to choose which objects you want to view from its suggested objects that are at their best right now. The Sky Tour is more structured. You make a full plan ahead of time and then more or less stick to it during the night. You can customize the plan, spending more or less time on an object. The advantage of the Sky Tour is efficiency. If you were doing a large observing project, such as the Herschel 400, it can help you maximize the number of objects you can get during the night. It's also a great way to plan for Messier Marathon. The advantage of Best Now is that you can take as long as you want on each object and decide on the fly what to look at. We'll be using Best Now mode. Let's have a look at the list I've been building. Now, it's not time to observe just yet, so the real-time tool isn't ready to show us anything. But I can review the list in the nightly planner. I'm going to observe for about 5 hours or so. Let's assume 10 minutes per object. There are 300 minutes in 5 hours, so that works out to 30 objects. It's a good idea to have more than I can observe, so I think 39 objects seems reasonable. In practice, I may not get to all of them, but that's okay. Better that than to run out. Let's have a quick look at the refresh rates. From the telescope control menu, select Configure Real-Time Refresh Rates. This menu may say telescope control, but it also has a few options that are important even if they're not controlling a telescope with SkyTools. And this is one of them. The real-time tool follows the current time. To do this, it periodically refreshes the telescope status, the data in the observing list, and any charts that are open, to keep everything up to date. This dialog controls how often these things are updated. We'll start with the charts down at the bottom. The sky doesn't move that fast, so it is unnecessary to refresh the charts quickly. Every 2 or even 5 minutes is fine for most purposes. The simulation charts are the overhead sky, naked eye, and finder charts, customized for your telescope or binoculars. The observing list refresh is important. If you have a long list and a slower device, a list refresh may take several seconds or even longer. The list refresh can interrupt what you're doing with the list, so you don't want it to occur too often. On the other hand, when the sky is changing quickly, such as during twilight, you want it to keep up with the sky. A good refresh rate for a list with less than 100 objects is every 90 seconds. We'll be using the Sky Tour at the telescope, but it always uses the current date, meaning that real time can't give you a preview of the tour ahead of time. So here's a big tip. The plan function on the nightly planner uses the same algorithm as the Sky Tour. So to preview the Sky Tour, I'm going to set it for the date I'm going to observe, the telescope, location, and observer, and then enable it. But first, I need to put my estimates for how long it will take to find each object and how long I want to look at each one. I'm going to assume that it will take 1 minute to find each target, and that I want to spend 5 minutes looking at each. This is something we can tweak later, even after we start observing, but for now, this will give us a good idea of how well our list works. So now a plan has been generated for the list. This column tells us the time to start each observation. This column tells us the view time, or how long each observation is planned to take. The default value is the number from up here. The plan is naturally sorted by the time to start observing. If you want to sort by other columns, disable the plan. If we look at the status area at the bottom, we can see that 36 of 38 objects were scheduled. We hand-picked the objects for this night, so one might think that they all should have been scheduled. But sometimes too many objects need to be observed during a finite amount of time, and they won't all fit. In that case, one or more may be left out. Here's another tip. How can we find out which object wasn't scheduled? I'll right-click on the checkmark column heading and clear the checks by selecting Uncheck All. Then I'll select Check Displayed. What this will do is place a check mark next to every object that is being displayed. The objects that weren't scheduled won't get a check mark. Next, I'll turn off the plan. At the bottom, we can see that all objects are now being displayed. I just need to look for the ones without a check mark, and it's M79 and NGC 366. We can see that they are only at best quality for a limited period of time at the start of the night, which is likely a factor in why they are being left out. So, what if I want to see M79? Well, what I can do is raise its priority level. This is the priority column. If I right-click next to M79 in the priority column, I can elevate the priority to high. And if I re-enable the plan, sure enough, now it's included. If I use the check marks again to follow a similar procedure to before, I can determine which object was replaced, and it turns out to be NGC 3631. Rather than increase the priority of M79, I could have lowered the priority of NGC 3631. To do that, I'll reset the priority for M79 and set a lower priority for NGC 3631. And sure enough, we get the same result. M79 has replaced NGC 3631. Okay, I'm back. It's the early evening, and I've set up my scope, which is a GOTO scope connected directly to SkyTools. I'll be using the real-time tool in SkyTour mode with the custom observing list that I created. I'll enable night vision mode, and by the way, there's a tutorial on using night vision mode. I'm using a red screen over my laptop, but I'll be using screen capture for this video, so you won't be seeing the added effects of the red screen. I've loaded the custom list that I created and set the mode to SkyTour. I'm going to set the finding time to 1 minute to give me a bit of time to locate the object in the eyepiece. I'll leave the view time at 5 minutes. I can change these as I go along if I want to. The SkyTour is designed to be heard. You need to have the voice enabled, and the volume needs to be high enough to hear at the telescope in order to get the full use out of it. Once you go to the eyepiece, it needs to be able to tell you when it's time to move on to the next object. The next thing to do is to update the weather. It's going to be 38 degrees Fahrenheit this evening with a humidity of 33%. I'll keep the seeing it good for now until I get an idea of what it is after the sky settles down after sunset. I'll set the quality to best only and the visibility to visible at any difficulty. Oh, and the double star splitability to good or better. I know I used these things when I created the list, but these settings will also help create an optimized sky tour. Here's a tip. I'm going to be logging my objects as I go, and I don't want to have to enter the conditions for every one of them. I'll right-click on any random object and select Create Log Entries, plural. This brings up the New Log Defaults dialog, which is used to set defaults for when you want to enter more than one object at a time. For instance, you might want to enter old logs from a paper logbook. But it also works for entering logs on the same night. What I want to do in this case is to type in a default for the weather conditions. All right, typing in good seeing, good transparency, few high clouds, and I need to be sure to save them. Let's have a quick look at the telescope control menu. Most of these options control the telescope, but there are a few general ones as well. I'll use this to close the connection when I'm done. These are all described in the help for the real-time tool. The motion controls may be useful for some people. This is like an on-screen hand controller. These buttons move the scope to the north, south, east, and west. North and south are flipped if this button is enabled. There are multiple selections for movement rates. This is 4 times the sidereal rate, 8 times, 16 degrees per second, etc. You can configure these rates via this button. If your mount supports it, you can enter manual tracking rates here. Type the rate in degrees per second and click Run. You could use this for a comet, minor planet, or Earth satellite in order to keep it centered. The SkyTools Object Info can tell you the rates for a comet or asteroid. I'll have to wait until the sky gets a bit darker. If we look at the tour, it has me finding the first star at 1929. It isn't even expected to be visible in the scope until 1930. That's because it gives me a minute to find it. That's cutting it unusually close. There are too many untamed variables to predict the moment when a star becomes visible that accurately. It might be a good idea to give me some extra time on this one. I'm going to right-click on the view time next to Lambda Ori and change it to 10 minutes. That should give me plenty of time to find this first object. I'm going to preview the object in the Finder chart so we can talk about the Finder chart a bit. There are other charts we can open too. With the GOTO scope, the eyepiece view is the most useful, so I'm going to select one view at a time and select the eyepiece view. I can select my widest field finding eyepiece, which is always the best one to start with. If the target is small or faint, I may need to identify the stars in the eyepiece in order to determine the exact place to look. So let's say I was looking for a small or faint object that wasn't obvious in the eyepiece. For scope on an equatorial mount, what I can do is to move the scope a bit toward the west while I'm looking in the eyepiece, and note the direction that the telescope moves. Then I can return to the chart on the screen and grab the circle where the arrow meets the field of view, and holding the mouse button down, drag it to match the orientation in the eyepiece. If I do this right, the orientation of the stars on the chart should match the orientation in the telescope, and that makes it very easy to pick out the patterns. Once those patterns are spotted in the eyepiece, I'll know where to look for that difficult target. Okay, the next step is to align my mount with the hand controller as soon as a few bright stars appear. All right, I'm back, and the mount is aligned. The next thing to do is to connect it to SkyTools.
Telescope connected.
All right, that seems to have worked okay. Here is the right ascension, declination, azimuth, altitude, and air mass for where the telescope is currently pointing. I'll start the sky tour now and wait for it to prompt me to slew to the first target, Lambda Ori. It tells me here how long I'll have to wait. In the meantime, let's do a quick configuration. I'll click Settings. If you don't want it to automatically speak the object info, remove this checkbox. I can also turn off the tutorial, which gives us extra prompts and instructions. And it's the same for the Finder chart if I don't want it to open. I like to know where I'm looking, so I'll let it automatically open. So now we just wait for it to get dark. Okay, it's telling me to slew to Lambda Ori now. I'll click the button to start the slew. It automatically opened the Finder chart like I told it to. This is what I should see in the eyepiece. The flashing X is the current position of the telescope. Okay, I'm at the eyepiece now, and I don't see the star. So I must have missed by a bit. Most of the time the target's obvious and in the field of view. But I know it's got to be close. And I see a glow just off to the left. I'll move it a bit, and there it is. It's obviously a double star, so I'm sure I got the right one. And back at the laptop, I'll click the sync button or press the space bar to synchronize the mount, which means it will update the position. Next, I'm going to try higher magnification eyepieces, and I can start a log by clicking the log button. It automatically opens for the scope I'm using, my location, the default weather I added earlier, and the current time. All I need to do is to type in my description of what I saw. Eventually, my allotted time is going to run out, and it will prompt me to move on to the next target. In this case, Beta Mon. If I finish early, I can move on by clicking Skip to Next Object. Unless you get really far ahead of the plan, it will move right on to the next one. If it tells me it's time to move on and I'm not done, then I can click Pause. When I'm ready, I can click Continue. Once my minute to find it is up, it's going to read me the object information. You can control how much information is read via the settings. I'll click Configure. This allows me to set how much information it reads to me. Check everything that you want to hear. This sets the maximum number of also known as designations to read. If there are notes attached to this object, I can have it read them to me. Or just the notes brief, or skip them altogether. It can also list objects in the same field of view or nearby. The rest of these are self-explanatory. If it bothers you, you can turn it all off. I find that, especially if I'm observing alone, it's nice to hear this information when I'm looking at the object. We'll speed things along until I get to 19P Borelli.
One minute. Start Salu. The telescope is slewing. Salute to Beta Mon completed. One minute. Start Salu. The telescope is slewing. Salute to the trapezium completed. One minute. Start Salute. The telescope is slewing. Salute to M66 completed. M66 is an intermediate spiral galaxy in Leo. It is magnitude 9.7, with an apparent size of 10.2 by 4.6 arc-minutes. M66 is also known as NGC 3627. M65 is an edge-on spiral galaxy in Leo. It is magnitude 10.1, with an apparent size of 7.6 by 2 arc-minutes. This galaxy is 41 megalight-years away. It is 90,000 light-years in diameter. M65 is also known as NGC 3623. One minute. Start Salute. The telescope is slewing. Salute to M79 completed. Start Salute. The telescope is slewing. Salute to Intergalactic Wanderer completed. Start Salute. The telescope is slewing. Salute to IC 443 completed. Start Salute. The telescope is slewing. Salute to 19P Borelli completed. (19P Borelli is a comet, located in Perseus. It is magnitude 10.7, the coma is 2.6 arc-minutes in diameter. The tail lies at position angle 70 degrees and should be about 0 degrees long. The last magnitude and diameter observations were on 2022, March 6th.
All right, I placed the finding eyepiece back in the scope, and the comet is obvious. I'm able to trace the tail fully with my dark adapted eye. One final tip before I get back to observing. If you find the SkyTools voice to be too loud, you can lower the volume on your computer. But you can also lower the volume only for the sounds from SkyTools if you still want to hear other things at a higher volume. To do that, right-click on the volume icon and select Open Volume Mixer. Look for SkyTools. In this case, the chart is open, so it shows the SkyTools chart. Lower this volume, and it will only affect sounds from SkyTools. Well, I'm going to get back to it now. If you have any questions, please feel free to ask on the SkyTools Visual Discussion Forum of the Skyhound Forums. I and others are standing by. Clear skies, and thanks for watching.